Okay, so today we are going to be talking about the Unit 4 Earth Systems notes. And so I like to start with Unit 4 at the beginning of the school year because I feel like the soil and the land and the climate that we have on Earth and what causes all of that is important to understand the ecosystems and the biomes that we live in. And so we're going to do things a little bit out of order, and we're going to start with Unit 4 first. So let's go ahead and jump into 4.1, Section 4.1, which is plate tectonics. Okay, so the Earth's structure, just probably this is a reminder from like either late elementary or junior high, intermediate school, maybe. I don't remember exactly when you go over this. But I'm sure that you've talked about the core of the Earth before. It's that really hard, dense center of the Earth, extremely, extremely hot. And then we have the mantle, which is the liquid layer of magma that surrounds that core. Beyond that, we have the asthenosphere, a solid, flexible outer layer of the mantle. It's beneath the lithosphere, so it's beneath where we actually live, but that's the asthenosphere, this solid, flexible layer that separates the magma from the lithosphere. And then the lithosphere is this thin, brittle layer of rock that basically floats on the mantle, and it's broken up into what we call tectonic plates. And then last is the crust, which is the very outer layer of the Earth, of the lithosphere, and it's actually where we live. Even if you were to like take a shovel and dig it into the ground, you're not going to hit the lithosphere. So the crust is basically where we get all of those biomes. We get soil and everything that kind of forms those biomes. Okay, so moving on. Another topic that you need to know, speaking of those plates of the lithosphere, the lithosphere, are the plate boundaries. And so understanding those different types of boundaries, there's three different boundaries: divergent, convergent, and transform boundaries. It is important if we look at the AP standards and what College Board says you need to know. You need to understand how those plates move and kind of what forms, what geological features form at each of those plate boundaries. So divergent plate boundaries, if we look at this picture over here, actually move away from each other. And when they move away, magma moves up into the place there, into the space that's made available. And that's called a magma plume. At these plate boundaries, we can form various things depending on where the boundary is. Okay, so if it's in the middle of the ocean, we end up with something called a mid-oceanic ridge. We also, if enough of that magma rises through the crust, we can form a volcano. We also get seafloor spreading, which is where new plates, new rock is added as those plates move, and it makes the plate actually bigger at the divergent boundary. And then rift valleys, if the boundary is on land, we end up with something called a rift valley. Okay, so it's really important that you know that information. A rift valley, I've had students ask me before what that is. It's basically if you've ever seen two mountains that are really spread apart. So you'll have this nice flat area, this valley in between the two mountains, and that's what a rift valley is. So we tend to just call it a valley. Okay, all right, and then we have convergent plate boundaries. Convergent plate boundaries actually push together. And so this leads to one plate is more dense, one plate is less dense. So the more dense plate is going to sink beneath the less dense plate, and we can see that here in this picture. And it'll actually, that plate then will continue pushing upwards. And we end up forming mountains. We also can form island arcs along coastlines. We generally see those. This pushing up and this moving underneath of the plate, like we see in the picture, can lead to earthquake activity or seismic activity. And then we can also end up with volcanoes because magma can actually squeeze between these two plates. If the space is far enough apart, magma can rise up and form a volcano as well. And then lastly, our transform plate boundaries. This is when two plates rub together. They slide past each other like this. And you can kind of see this in the picture, although my face is kind of, let me get rid of my webcam here so that you can really see this picture. And this is where, these are the types of plates that we have out in California. And so we probably all know that California is very prone to earthquakes. It's because there's the sliding, there's a lot of friction. And when the plate finally moves and breaks free of the other plate as it's sliding across, that creates a tremendous amount of energy. And it has to go somewhere, and it goes out in waves. That energy kind of bursts out and causes that earthquake. Okay, so that is plate boundaries. That's what you need to know. Okay, another really important geologic and atmospheric event that occurs, or process, I guess should call it a process, not necessarily an event, are things called convection cycles. And so convection cycles, we can see here, are formed by temperature, basically. And so the magma that's heated by the Earth's core rises towards the lithosphere. And as it rises, we can see here, because it's at a divergent plate, it rises and then it has nowhere to go. So it kind of circles back around. It begins to cool off because it's further away from the core. It cools off, it sinks, and then it creates this like cycle. I think of it like a conveyor belt, actually. That's what causes the plates to move. These convection currents. Now we're going to talk about convection currents again when we talk about the atmosphere coming up in this unit. So just understand that term, what a convection current is. It's where the heat actually causes the particles to rise, whether that's air or liquid, those particles. And then it has nowhere to go, or it starts to cool and it kind of goes out. It's kind of pushing out. And then it creates this like cycle pattern that goes in circles like this. Okay, so magma rising and cools, it expands, it forces those oceanic plates apart. It creates, like we said, ridges, volcanoes, or seafloor spreading. It cools, it solidifies into new lithosphere, and it sinks back down. And it's just that constant conveyor belt effect is what I like to say. Okay, next slide. So again, you can pause the video if you want to write any of this down, but it's kind of just repeating. I like these pictures, so I added this slide and kind of gave you some examples of where these types of plate boundaries are. But you don't actually have to know oceanic, continental, continental. You don't have to know those terms. So really, it's just a nice review and it's nice pictures. And if you want to learn a little bit more about the plate boundaries, or you've learned about these in the past, that's there for you. Okay. And again, just a little bit more information about a transform plate boundary, but again, we've already gone over this. This is just another picture. Again, I just like to show lots of pictures so that you have this information in your head. Okay, so another really important concept is that we actually track where all of these earthquakes are happening. And you can go to the NOAA, the NOAA, NOAA.gov, I think it is. If you look up NOAA online, you'll find it. But you can actually see where earthquakes are happening around the world currently, like at this minute, at this second. It's pretty cool. But anyway, you can see here that when we track these earthquakes, we notice patterns. And these patterns are all related to the plate boundaries. They kind of draw a nice circle around and kind of define where those boundaries are. And I like this map because it shows, we can make predictions. Scientists use these maps to say, hey, there's a lot of activity or a lot of movement in this area. We're probably going to get an earthquake. And we're actually starting to track these things, and we're able to predict earthquakes much better than we used to in the past. Anyway, okay, so that prediction piece of these tectonic plate maps are just really important, as you can imagine, okay? This is, again, something you don't necessarily need to know, but this is the Ring of Fire. And we call it that because this is where there's a lot of seismic activity. So that's really kind of a fun little name that geologists came up with, the Ring of Fire. So that's, again, something you don't need to know, just a little bit of information there for you. Okay. Excuse me. So at the end of every section, there will be a practice FRQ. FRQs are free response questions. On your AP test at the end of the year, you're going to have 3 FRQs, and they equal 40% of your AP test grade. We're going to practice FRQs throughout the entire year. Like each unit, we will do something to practice FRQs. You will also have FRQs on your test. So, like your unit tests. So, be prepared for that. We're going to be practicing FRQs a lot. College Board's very specific about how they want you to answer various types of questions. And so, again, you'll get lots of information. Don't be overwhelmed by me telling you this, but we're going to practice like doing some free response questions every single set of notes that we do. And I will give you the answers to these as well. They'll be available for you on OneNote. So our first practice FRQ, it says explain how subduction leads to volcanic activity. So explain how subduction leads to volcanic activity. I'll see you guys next time when we talk about 4.2 soil formation and erosion. And we've got a pretty big lab we're going to do with that unit. So I'll see you later. If you have any questions, make sure you reach out to me in class.